Hi girls, 2010 B2, and this is an oblique planes question. So the graphic on the right shows a skyscraper which is located in Florida. The front face of the building contains a curved recess as shown. Okay, so we'll need to get that curved recess. Draw the given plan and elevation of the building. The elevation of the curve may be ignored for this part, so we're not doing the elevation of the curve just yet. Then you're asked to complete the elevation of the curve by getting the vertical and horizontal traces of the oblique plane contained on that front face. Okay, so we're using the oblique plane to solve it. The first thing you will notice about this, it's scale 1:100. That means you're dropping 2 noughts. So instead of it being 1,500, it's just 15, 135, 100, 25, 30, 65. Okay, 62, and the angle is 55 degrees directly underneath. We are going to start off by drawing the plan first. Okay, so 2010 B2 for anyone that has forgotten. Okay, and what I need to get first is my protractor in order to measure the 55-degree angle. And you can start anywhere with this. So I'm just going to pick a place to start. I'm going to draw a vertical line just to make this easy for me to measure the 55 degrees accurately. So I did a vertical and horizontal line just to measure the 55 degrees as accurately as I can. So I'm going to do all of the measurements that I was being asked. So the measurements were 30. The overall measurement was 65. And from the far side, it was back 25. Okay, and I'll need to come perpendicular to this in order to finish off the shape, and the shape is 100 wide. Okay, so sliding our set square is perpendicular. Just going to double check the measurements again. So yeah, 65 wide, 25 back, and 30 forward, grand. And it's 100 wide. And what I need to do is I need to put in a curve that has a radius of 62. So you're going to grab your compass and you're going to measure 62 in your compass in order to get the center point. That's what we don't have. So measure 62 on your compass. And from each corner, we're going to strike an arc. That will get the center point to which we can draw that arc in. Okay, so that's the plan finished. It doesn't matter how much you leave for the elevation, but just leave a little gap like you've always done. Okay, I realise now that I mightn't have enough space for my entire elevation, but sure, look, I'll do is, if I have to stick on a sheet, I'll have to stick on a sheet. Okay, so I need a total of 135 plus 15, that's 150 for my elevation. Okay. Yeah, I'm a little bit short, so what I'm going to do is stick on a sheet just on top here so I have enough space. Okay, so attaching that with masking tape or whatever you like, I just slipped it on underneath. I'm just going to stick it on each side. And just measuring up that 150. Okay, so it was 135 first, and then the 15 to finish off. Okay, and transfer those widths across. And I'm just going to continue on these other points up vertically also. Now, so I can start kind of drawing the shape as best I can. So these 2 points are on the ground. These 2 points are up the overall 150. So follow them up. That's the 150 there and there. There's a little step at the back. This will be your hidden detail to there and your hidden detail to there. Oh no, that will be actually visible. Okay, and it's jutting out of the side. And that will be heavy on the outside. Went a little bit too long with that. Okay, so again, yeah, these are my slope surfaces at the front. And this is the oblique plane that we're talking about. Okay, so that is part A of the question done. It was drawing the elevation as I have it and the plan without the curved surface, and I'm just going to label that part A. Part B of the question is complete the elevation of the drawing with the curve. Now, I actually can't do that curve without actually having either done an auxiliary to transfer heights over here or by getting the oblique plane. Now, as you would have seen from every other question that we've looked at, when you have 2 points on the ground, okay, in plan, that gets you your horizontal trace. So these 2 points are on the ground and that's on my surface. So because I have those, these 2 points are on the ground and that will represent my horizontal trace. So I can just draw that line in heavy, where it touches the XY line. So you can't actually see that just yet. My XY line isn't long enough. Okay, so once I have that, that is my HT. Okay, so all I did was I joined the 2 points that were on the ground together and that created my HT. I know this is quite large, but this is the best we can do for the moment. So that's my HT found. Now that I have that, I can find my vertical trace. So let's say these 2 points are also on the same oblique plane, because this is the oblique plane here, it's all of that. Okay, so these are 2 points that are also on the oblique plane, and guess what, we have them in elevation, they're here. So because we actually have the height of them, if we transfer these 2 points parallel to the HT, bring it up and across to meet it, we'll get a point in our vertical trace. And once we have that, we can begin to get the curve easily after that. So all I'm going to do is bring these 2 points parallel, see where they touch on the ground, which I've just done, bring them up vertically, and the height across to meet it. And I have 1 point on my vertical trace now, so I can draw my vertical trace in. Okay, so now I have my V, T, H. Okay, so all of that's in now. In order to find the curve, you need points on the curve. Now, you would have seen this before. You could divide it up with your 30, 60 if you like, but you mightn't get enough points. So I'm just going to locate a series of points all along the surface. And what I'm going to do for this is, because it's symmetrical, I'm definitely going to get midway, which is the 50 mil. but I'm going to measure every 10 mil, and I'm going to get a number of points on this surface, 10 in fact. And all I'm going to do is, again, transfer these points that were 10 mil apart onto the curve. So you can see I'm finding them all there now. 1, 2, 3, 4, 5, 6, 7, 8, 9, and obviously the end point 10. So I'm going to call that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you will start to notice 0 and 10 are the same height there on the ground. That's 0 and that's 10. 1 and 9 are the same. 2 and 8 will be the same. 3 and 7, 4 and 6, and 5. So in order to find any of those points, what you're going to do is slide your set square, and you can see 1 and 9 are in line with each other and they touch the ground there. You'll bring them up till they touch the VT and across, and you'll again bring up 1 and 9 to meet them. Okay, so I'm just going to actually transfer all of the points, just because as I'm sliding my set squares, I might as well hit all the birds at the one stone. Okay, so 3 and 7, 4 and 6, and finally 5. So now I've got the 5 or 6 points on the ground. I now need my T-square in order to transfer those points up to see where they touch on the vertical trace. That gets me heights. So the first one was the point 1 and 9. So 1 and 9, when I bring it up, it touches the vertical trace right here. You're going to bring that point across. So 1 and 9 is this height. And then bring 1 up and 9 up to that line. Do the same with 2 and 8. So 2 and 8 is the next one. And the next one then was 3 and 7. Might as well bring 8 up. The next one was 4 and 6. And the last one was 5. Okay, so you can see I've brought them up, and I'm after getting heights, and I'm going to bring those heights across. So the next one is 2 and 8, then 3 and 7, then 4 and 6, and then 5 up on top. And this is getting the heights for all of those points. So 2 and 6 are the next one. So 2 is on the next height. Sorry, 2 and 8, apologies. 2 and 8, so they're there, 2 and 8. The first one was 1 and 9. The next one was 3 and 7. The next one is 4 and 6. And the last one there is 5 on the overall highest point, 5. You can now see that I have my enough points on this surface to join that curve together. And join it as accurately or as good as you can. Okay, so I'm just going to refer back to the question at this stage. So B was complete the elevation by drawing the curve in the front face. Now you actually needed the vertical and horizontal trace for that, but we actually have that. Determine the horizontal and vertical traces for the oblique plane. So we've done parts B and C. So B is obviously the curve, and C is getting the oblique plane itself. Now you needed the oblique plane to actually solve this question, and just bear with me on that. The last question, part D of the question, is determine the true angle between the traces. Now this is the angle between both surfaces. So there's a couple of different ways of doing this, and this is a question you've never actually seen before. So what we have at the minute is we have two different angles going on, but we need to get the angle between both of them together. Now there's a couple of ways of doing this, and we haven't seen it yet before, but what we have done is we have found where this entire oblique plane, so I'm just going to show it in plan again. Okay, now I'm just going to shade it in. This is the entire oblique plane, all of that, okay? And we have found its horizontal trace because it touches on the ground. So this line is quite important. Okay, what we're going to do is knock the other plane down flat. And there's a couple of ways of doing that. Yes, you could look along it, rebat it down and bring it across and find a point on it and you'll get the angle. So we might actually do that. Or a second way of doing it is where the oblique plane finishes, which is this point. Okay, we have its height. We could come out perpendicular to that by doing the auxiliary essentially and take its height from elevation, so the height that you had in elevation, and transfer it into plan. And then you also have the angle found. So there's a couple of ways of doing this and that's what I'm going to go for. So just you'll be grabbing your compass and we're going to transfer a couple of heights from this. Okay. And again, I hope I don't have to stick on more paper. Kind of looking at this and thinking I might. The reason I'm not going to do the auxiliary is because I am going to have to stick on a sheet. So I'm going to just show you a second way of doing this. So you could look along here, draw an XY line, take your heights that you had normally, get the angle, rebat it around and get the second angle underneath. And that'll get the true angle for you. Or, because the angle we used to get when you take the auxiliary for the first time is just to the horizontal plane. But this is the angle between both planes. So it's the angle between here and here together. So what I am doing is this plane, we have the ground of it. What we're going to do is take the top of it, which is this line here, and transfer it into a new auxiliary down in plan. So we are doing an auxiliary for this. So I've come out perpendicular. Okay, and it's perpendicular to the HT. I'm going to take the height of this point, which is quite large on your compass, by the way, so you're going to have to extend your compass like I am doing here now. Take the heights to the vertical trace. And from your new XY line, which is this line here, this is your new XY line, you're just going to strike it off. And as you can see, it's going way off my page. I'm going to have to stick on another page. Again, I'm just sticking on a page just to the right hand side so you can see this being extended on. Okay, and I had come out perpendicular, so I'm just going to extend that line a little bit further because my line wasn't long enough. Okay, and again, I'm taking the height from the elevation, which is this height, to the vertical trace. And I'm moving that point to my new XY line, which is this line here, at that individual point. Okay, move it there and strike it off. Okay, it's quite long. Okay, this is a point that creates an angle that's in between the two planes. So I've between one plane and the other plane. So I've transferred the vertical plane to this line. Okay, and the angle inside here is the angle between both planes. So all you're going to do is measure that angle with your protractor. And that's the angle between both planes. I'm getting roughly 74 degrees roughly. So the angle between both planes is 74 degrees. When we usually come out here and come out along the HT and we do the XY line and we get the angle normally, that's the angle to the horizontal plane. Okay, so that's the angle just to this surface, but we want the angle in between both of them. So determine the true angle between the traces, and that's what we've just done here, which you hadn't seen before. Okay, that's the end of the question. It is quite a large one. If you have to stick on a sheet, I've had to stick on two, but if you have to stick on a sheet, it's not the worst thing in the world. Just get an A4 sheet, stick it on where you need it, and that's it done.